If you look up at the night sky in the constellation Sagittarius, you're looking toward the center of our galaxy, but you can't see it. The galactic center is hidden behind thick clouds of dust and gas that block visible light. For centuries, it remained a mystery. Only in the last few decades, with radio, infrared, and X-ray telescopes, have we finally pierced the veil. What we found is astonishing. The center of the Milky Way is not a quiet, empty place. It's a chaotic, violent region, packed with stars, swirling gas clouds, exploding supernovae, and at its very heart, a supermassive black hole called Sagittarius A. Today, we're going to explore this extreme environment, the closest galactic nucleus we can study in detail, and discover what it tells us about our cosmic home. The zone of avoidance. The galactic center is about 26,000 light-years from Earth in the direction of Sagittarius. But between us and it lies the galactic plane, the dense disk of the Milky Way. This disk is filled with dust grains that scatter and absorb visible light. The extinction is so severe that visible light from the center is blocked by a factor of about 1 trillion. To see the center, astronomers must use longer wavelengths that penetrate dust. Infrared light gets through partially. Radio waves pass through almost completely. X-rays reveal the hottest, most energetic processes. By combining observations across the electromagnetic spectrum, we have built a picture of a region that is invisible to the human eye. It's like having X-ray vision, seeing what cannot be seen. The nuclear star cluster. At the center of our galaxy is a dense cluster of stars called the nuclear star cluster. It's about 6 light-years across, roughly the distance from the Sun to the nearest star, Proxima Centauri. Within that small volume, there are millions of stars. For comparison, the same volume around the Sun contains only a handful of stars. The stars in the nuclear cluster are mostly old red giants. But there are also young, massive stars that shouldn't be there. They're too young to have migrated from elsewhere. Their presence suggests that star formation is ongoing, even in this extreme environment. The density of stars is so high that stellar collisions are common. Occasionally, a star might be torn apart by the black hole's gravity. The supermassive black hole. At the very center of the star cluster lies Sagittarius A. It's a supermassive black hole with a mass of about 4 million suns. Unlike the monster in M87, which is 6.5 billion solar masses, ours is relatively small, but it's still enormous. Its event horizon is about 24 million kilometers across, roughly 1/3 of Mercury's orbit. Sagittarius A is surprisingly quiet. It's not actively feeding on large amounts of gas. Occasionally, it flares up when it swallows a small cloud or a star. In 2022, the Event Horizon Telescope released an image of Sagittarius A's star's shadow and photon sphere, similar to the M87 image, but smaller and more dynamic. The black hole is there, patient and hungry, waiting for its next meal. Orbiting stars. One of the most remarkable achievements in modern astronomy is the tracking of stars orbiting Sagittarius A star. For decades, teams led by Andrea Ghez, UCLA, and Reinhard Genzel, MPE, have used adaptive optics to follow these stars. The orbits take decades to complete, but we now have full orbits for several of them. The closest star, S2, also called S0-2, comes within 120 astronomical units of the black hole, about 4 times Neptune's distance from the Sun. At that point, it's moving at 2.5% of the speed of light. The observations perfectly match general relativity, including the gravitational redshift and the precession of the orbit. For this work, Ghez and Genzel shared the 2020 Nobel Prize in Physics. The galactic center is our best laboratory for testing gravity. The central molecular zone. Surrounding the nuclear star cluster is the central molecular zone, a region of dense gas clouds spanning about 1,000 light-years. These clouds are much denser and hotter than typical molecular clouds in the galaxy. They are also highly turbulent, likely stirred by the black hole's energy output and by supernova explosions. Within this zone, new stars are forming, but at a surprisingly slow rate given the amount of gas. Something is suppressing star formation, perhaps the intense magnetic fields or the turbulence itself. The central molecular zone also contains strange filaments, some of which are radio-emitting structures pointing toward the black hole. Their origin is still debated. Giant structures above and below. The galactic center doesn't just affect its immediate surroundings. It has shaped the entire galaxy. Evidence for this came in 2010, when the Fermi Gamma-Ray Space Telescope discovered two enormous bubbles extending about 25,000 light-years above and below the galactic plane, the Fermi bubbles. These bubbles emit gamma rays and X-rays, and they are filled with high-energy particles. The most likely explanation is that the supermassive black hole was much more active in the past. A few million years ago, Sagittarius A star may have consumed a large amount of gas, producing jets or outflows that inflated these bubbles. The Fermi bubbles are ghostly reminders of a time when our black hole was an active galactic nucleus. The future of the galactic center. What will happen to the galactic center in the future? In about 4.5 billion years, the Milky Way will merge with the Andromeda Galaxy. The two supermassive black holes will spiral together and eventually merge, creating a single, more massive black hole. The merger will release a burst of gravitational waves and likely trigger a period of intense activity. In the nearer future, astronomers will continue monitoring Sagittarius A star and its orbiting stars. The next generation of telescopes, including the Extremely Large Telescope, ELT, including the Extremely Large Telescope, ELT, and space-based interferometers, will resolve even finer details. We may see stars being torn apart by the black hole. We may detect pulsars orbiting close to the event horizon, providing even more precise tests of gravity. The galactic center will remain a focus of research for decades to come. The violent heart of our galaxy. The center of our galaxy is not a place you would want to visit. It's filled with radiation, turbulence, and a giant black hole that occasionally shreds stars. But it's also one of the most fascinating places in the universe. It's our nearest galactic nucleus, our only chance to study a supermassive black hole and its environment up close. Every time we look at the galactic center, we learn something new about gravity, star formation, and the history of our galaxy. We see the past, light that left 26,000 years ago, and we glimpse the future, when our black hole may awaken again. The heart of the Milky Way is dark, hidden, and violent. But thanks to modern astronomy, we are finally seeing it clearly. What do you think? Would you want to send a probe to the galactic center, or is it too dangerous? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.